Thanks. Hello, everyone. My name is Kyle Teagarden. I'm the product marketing manager for Azure Cache for Redis, and I'm joined by Yigu, who is the principal PM for Azure Cache for Redis. And I'm just going to spend some time today for your lunchtime, I guess, talking about this service and some of the news we have. We have a new offering that we're really excited about as well. So I'm going to kick things off just with a little poll. Excuse me, my screen works. There we go. So quick pulse check. Go ahead and raise your hand in Teams if you're familiar with Azure Cache for Redis. And don't worry, I'm not going to call on you. Just want to get a sense of people's current level of knowledge. So I see a couple hands, I think 3 hands, 4 hands. All right, so maybe 4 or 5 people, not too many of you. That's totally okay. In fact, that's really good. So I'm going to spend a little time first talking about what Azure Cache for Redis and what Redis is, and then dive into these new features we have that we're really excited about. One other note here before I really dive in is please go ahead and use the chat to ask questions during the presentation. We have some time reserved at the end to do Q&A, but it always helps to see those questions come in. If we don't answer them during the presentation, we'll answer them during the Q&A session. So don't hesitate. All right, so first thing, what is Redis? So those of you that know Redis, you probably know this already, but for those of you that don't, Redis is a NoSQL in-memory data store, and it's commonly used as a cache. So in practical terms, it's a fairly simple data store. A key value means that you assign some data to a key, and then when you put that key back in, you get the data back out. So fairly straightforward there, but there's a few things that make Redis really useful and make people love it. The first is speed. So it's an in-memory database as opposed to most databases which run on disk. And that means it's extremely fast. We're talking sub-millisecond latencies, so much faster than a traditional database. The second reason is scale. Redis is really good at scaling out. It's NoSQL. It's kind of designed to be able to scale out quickly and meet increasing demands. So it can handle just massive throughput. We're talking many millions of requests per second at sub-millisecond latencies. So extremely high performance there. And then finally is simplicity. And as I mentioned, it's a key value data store. So it's fairly straightforward to use, and it's perfect for caching and storing temporary data. So combine these things together, and the result is that Redis, as an open source technology, has been the most loved database in Stack Overflow's developer survey for 4 years in a row now. That just speaks to its influence, especially in the open source community. And of course, Redis is the open source technology. It's widely used in the industry. And on Azure, we have a managed version of that called Azure Cache for Redis. And that's all the Redis features that you love, but made easier because it's all managed for you on Azure. So easier integration with other Azure services and things like configuration, patching, updates, hardware provisioning, and especially scaling are all done for you. So a lot of perks to running as a managed PaaS service. So in terms of what people do with Azure Cache for Redis, we see 4 major use cases. And I'm going to touch on the first 3 because those are the biggest ones. Those are the ones that people use the most, and dive a little deeper into those. So the one we see the most is as a distributed cache. And this is a fairly simple and commonly used architecture where you probably have an application, maybe that's running on Azure, part of app service or an API gateway, or even just on a VM. And that application is going to be interfacing with your data layer, probably a database. By adding Azure Cache for Redis in between, what you do first is you check to see if that data is available in the cache. And if it's not, then you go to the database. But if it is available in the cache, you get that data back much faster. And you also reduce the load on the database, meaning that you don't need to provision as large of a database, saving you money. And of course, you're increasing speed and throughput at the same time. So, this is, like I said, a common architecture, but it's a really powerful way to speed up an application and make it scale better. And so this is used all the time for a variety of applications. One common application is to store frequently accessed data in the cache. So imagine a retail website. You might store things like inventory or pricing data in the cache because that data doesn't change too often, but it's also being pulled constantly. So, as you have thousands of users coming to your website requesting that same price over and over again, putting that in a cache rather than a database makes it much faster and a much more efficient architecture. It's also really good for things like handling traffic spikes. So, as you can imagine, some services are going to have huge spikes during major events. Like one example here is the Nobel Prize website uses Azure Cache for Redis. And of course, the traffic they're going to get when they announce the Nobel Prizes is going to be massively higher than on a normal day. And Redis helps them handle that scale. Another example I mentioned here is Chipotle, which, if you're not familiar, in the US is a quick service food chain that makes very tasty burritos. They use Azure Cache for Redis for this reason, to improve the website performance during the rushes they get at lunch and dinner time to their website. The second most common example we see is Azure Cache for Redis being used as a session store. So in this case, it's not really going in between your application and a database. In some ways, it kind of is that data layer, but for storing temporary data. A good example here is something like a shopping cart on an e-commerce site. As you purchase items and you save them in a shopping cart, you can put that in a database, but it's just not as efficient. Using Redis is faster, it scales better, and it's typically much cheaper too. But there's a lot of uses for a session store. Things like storing user metadata, storing cookies, session tokens. There's a lot of stuff that a website might have that needs to store it temporarily, where a database is overkill and not fast enough. So another example here is Geico, a US insurer. They're a big Azure user. They use Azure Cache for Redis to store information on insurance quotes. So if you're like me, you use Geico Insurance, you go to their website, you input a lot of information like your name and the car you have and income level and stuff like that. That all needs to be saved somewhere. And Redis is just a perfect place to put that, that's efficient, fast, and cheap. And then the final use case we like to talk about is messaging. And so this case, there's a variety of ways to do this. So Redis has a built-in publish and subscribe functionality. It's used in a lot of queue services. And it also has a streams capability that's similar in some ways to Kafka. But all of these are kind of used for the same thing. How do you send information or messages between services or data sources? These are things like streaming data from stock information or financial information, handling chat messages, or just generic communication between microservices. Azure Cache Redis is a great way to do that. We have an example down there from Mars. It's a pet care company that used this for a microservices application. Another good example is the service we're using right now, Microsoft Teams, that uses Redis extensively to help scale and to handle some of these messages. So, we can talk about these use cases and give you a sense of what Redis is used for. That doesn't necessarily answer the question of why Redis is used. And I think part of the answer is something you can see here. And what we did in this case was we actually hired a third party to benchmark Azure Cache for Redis and the performance boost that it gave to a simple application before and after it was added. So basically, it was like a really simple retail website application that was using app service and Azure SQL database as the backend. And one version of it just had that, and the second version was the same setup, but also added Azure Cache for Redis as a session store and as a distributed cache. And then we basically ramped up the traffic to see how the performance was. And the results were pretty stunning, that we saw 9 times higher throughput in terms of transactions per second by adding Azure Cache for Redis, and also simultaneously 11 times faster performance. So latency was greatly reduced by adding Azure Cache for Redis. And the other thing that's not shown on this slide is that the configuration we used with Azure Cache for Redis was cheaper because we were able to provision a smaller Azure SQL database. So there's kind of a trifecta here of higher throughput, faster performance, and lower cost. And that's the power of caching. You're not going to get this in every situation, but in a lot of use cases, it can be extremely effective at a low cost. So let's move on to talk about this new offering that I mentioned. right? So Azure Cache Redis right now, we had 3 tiers, the basic, standard, and premium tier, and we just added 2 new tiers, and these went GA in March at Ignite. And these tiers build upon open source Redis and add new features that are actually part of Redis Labs, their Redis Enterprise offering. So these are kind of above and beyond your typical open source features. And there's a few things to highlight here. So one is much higher availability, right? Our typical SLA is 3 nines. With these new tiers, it's up to 5 nines, so much higher. And then there's some cool new features in terms of how you can geo-distribute data and also how you use that data. And I'm going to walk through a few of these here in the next 5 minutes. So one thing we mentioned is called Redis on Flash. And this is a way to make the cache sizes much larger. So our typical caches, they run up to, I think, 120 gigabytes per cache, which you can scale out 10 times. So, 1.2 terabytes. Well, with Redis on Flash, which is part of our enterprise flash tiers, not only do you use the DRAM on these VMs, but we also add ability to use NVMe flash storage as well. So you're using both simultaneously. So you get kind of the speed of the DRAM, and then the flash memory is almost as fast, but that allows us to have much greater scale with very little performance hit. So we're talking 10 times larger cache sizes, up to 13 terabytes in a single cache, with clustering. And also much lower prices per gigabyte. So this is great for solutions where you just need a huge cache space. And if you're okay with almost as good performance, this is perfect. Other big features of the enterprise tier include Redis Enterprise modules. And these are special data types that are really useful for specific use cases. So, just kind of walking through these left from right. Redis Blooms is a probabilistic data structure. So it enables things like Bloom and Cuckoo filters, which check for item membership in a really efficient way. So deduplication is a really common use case for this, where you're checking to see, is this email address or is this name in my cache? And you can find out really fast in a very memory efficient way. Redis Search is a real-time secondary index and search engine that's built into Redis. It's really, really fast, which is useful, and it's already part of Redis, so it's you don't have to have a separate service to do search. And this is really powerful for things like when you store inventory information inside of Azure Cache for Redis. Again, your data is already there, and so you can add search as part of this existing service that you're already using, and expose that to users. So you can do this really fast search through your inventory that's cached in Redis, and that is much faster than trying to do it through a database. And then finally, Redis time series is a time series data structure for Azure Cache for Redis, really useful for things like sampling data. IoT applications are really common with this. And you can do things like downsampling and some data analysis, all in memory with Redis. So some really cool applications here. And then I think the two biggest things to talk about first is availability, right? So on the left, you can see the default with Redis is 3 nines, and that's pretty typical across the industry with managed Redis solutions. But with this new tier, there's 2 new options. So one is using Redis in multiple availability zones, which gives you 4 nines. And then if you use that across regions as well, which I'll talk some more about, you get up to 5 nines. And that's a huge difference in availability. I mean, 3 nines is good, but 5 nines is incredible. And that really opens Redis up to be used in a lot of applications that are mission critical. So we're seeing a lot of interest from financial services, for instance, with this, and for retail, where having a few seconds of downtime is a big deal. And adding 2 additional nines makes it a really big difference. So to talk a little more about active Geo Replication, I think this is maybe the most important feature of these new tiers, which is this enables you to read and write simultaneously on linked caches across the globe, right? So typically, caches are separate. If you change one, it's not going to change another in a different region. But with Active Geo, you can link the two, and then automatically updating one updates another one. And what that means is you can create worldwide caches with essentially local latency. which is a huge performance benefit. It simplifies applications a lot because you don't have to worry as much about data consistency. And it also, as I mentioned before, increases availability. So a few examples of what this looks like. One is handling user sessions that are roaming. So example here might be, let's say you're a coffee chain in the UK, you have an app that users used, and you store things like their favorite order, or the last, like their order history, for instance. And that's all being saved in a Redis cache for quick retrieval. If a user of that application takes the channel and goes to Paris or to Milan, their performance of the application is going to get worse because typically the cache that app is looking at is still based in the UK, and the latency on the network to get to that cache is going to be greater. Even greater if they took a flight someplace else around the world. Well, with active geo replication, all their information from their user session or for their favorite coffee order can be duplicated across caches seamlessly. And so the application can simply switch to the nearest cache that has all the same data, update that cache, and it updates their cache at home automatically. So a great way to boost performance and just seamlessly handle that data kind of consistency problem. Number two, handle regional failures. Right, that's why the availability is higher. If one region goes down for whatever reason, if a meteor hits that region, your data is safe because it has automatically been duplicated to other regions. So that's just a really powerful way to boost availability. And then finally, it's useful for broad geo-distributed applications. So a great example here would be like a mobile game. Most games now are available worldwide. And let's say you have a leaderboard in that game. You're tracking everyone's high scores across the globe. Well, if you're doing that on a cache by cache basis, it's tough to synchronize those together. But with Azure Cache for Redis, you can link those caches all together and just update your local cache with the new high score and create a global leaderboard that automatically updates all the other ones as well. So it really simplifies that task from a global perspective. So we think this is a really groundbreaking update. And to dive a little more into active geo replication, I'm going to turn it over to my colleague Yi, who has a demo to show. So Yi, you want to take it away?
Sure. Thank you, Kyle. So let me switch to my screen. Okay. What we have here is a demo that illustrates a typical retail scenario. So what we have is an app that runs in two different Azure regions, one on the East Coast and one on the West Coast. And each of these uses a local instance of cache. So there are two cache instances. Again, one on the East Coast and one on the West Coast. These two cache instances are linked together using the active geo replication that Kyle just talked about. And because of that, the compute instances that are running in the two different AKS clusters are talking to the cache instances locally, but are able to share the data across. So before we have the active geo replication capability, what happens is that because the open source Redis only allows you to write to a single primary. So what happens is that users on the two sites, they may hit the compute instances locally or in the region that's closest to them. But when the compute instances does any updates, it will have to go to either the instance on the East Coast or the one on the West Coast. And again, that's because the open source version only allows you to do write on one side. And then once the update happens, the change will get replicated to the other side. But you can only use one of these to do updates. Now with active geo replication, you can do the updates simultaneously in both regions, and then the Redis Enterprise software has the smarts to synchronize the data across the two regions and automatically reconcile any conflicts if necessary. So with that, I'm going to show you the demo. So what we have here is a website that sells T-shirts, and I have two instances, as you can see. One connected to our East Coast endpoint, and the other one is connected to our West Coast endpoint. So imagine in a real deployment, what happens is that you use load balancers to actually distribute the sessions based on the user's location, and you'll guide the user to the closest instance that you have. So what I want to show you here is that here I'm showing three items. Below the items are the inventory level for each item. So as you can see, the first one has 9 available currently. The second one has 12, and the third one has 5. So what happens is that if I'm a user on the East Coast and I say, okay, I want to purchase this particular item, let's say the first one, I click on this, and as you'll see that as I purchase this T-shirt, the inventory level gets decremented, and in real time, the new available quantity gets reflected across both instances. And I can do this from the West Coast as well. So I can toggle between the two, and I can run this down, and again, in both instances, it will show that this particular item has already been sold out. So it's a simple demo, but it illustrates the power that comes with the active geo replication. So with that, I'm going to hand it back to you, Kyle.
Sounds good. So I think we just have 6 more minutes, and that leaves us a little time for questions. So why don't we go ahead and jump into that? Anyone have questions?
How can Singapore not replicate to Hong Kong? Is there an option there?
So we'll point to Yi for that question. I want to say the enterprise tier is available in Singapore right now, but I don't know if it is available yet in Hong Kong.
Yeah,
right, but the origin pair is Hong Kong, isn't it, for Singapore?
So by default, your data will stay in region. So unless you configure another instances that you link through active geo replication in Hong Kong, your data in Singapore will not leave Singapore.
Not accessible, you said. Okay. It will not automatically replicate to Hong Kong. Okay.
No. No, we enforce regional data residency.
Okay, thank you.
Good clarification. Good question. Looks like Richa. I'm not sure if I said your name right. Do you have a question?
That's right. Hello. Lovely session. So thank you so much for sharing this. I just wanted to ask, have you implemented this in any of the banking application? And if yes, then what is the observation and what are the recommendation if it have to be introduced between a web app and Azure SQL DB in a banking application?
Yeah, so maybe I can take that a little bit. So yeah, we've had some financial companies that are pretty interested in this. Like I said, it GA'd in March, so I don't think we have any public success stories to share quite yet. I think the one thing to think about is the data you want to put in Redis should be limited to stuff that, like it shouldn't be a transactional database, right? So I think a lot of companies are using this for more of that session store, storing user information kind of applications on the banking side more than transactions. But it does fit the use case well in that banks tend to be global. They tend to have a ton of data, and active geo replication tends to be really effective for that. So I'm guessing that probably didn't fully answer your question, but anything specific in the banking space that you were interested in?
I am. I may ping you offline with the design
Yeah.
to take some recommendation from you.
Yeah, you're absolutely welcome to do so.
Thank you.
Mm-hmm.
Are there any concerns as far as leaving geo boundaries outside for a U.S. customer that doesn't want their data? Can they get to pick and choose what regions, or is it globally aware and customers can't pick where their data gets replicated?
I'll let you handle that one. I think there's a
Yeah. So in general, our caches are regional based. So when you create your cache instances, you specify which Azure region that you want to place that cache in, and so that way you can control where the caches are, and therefore where your data are.
Yeah, when you set up the cache, it's a menu. You can actually choose which region you want to geo distribute to. These are great questions. I think we have 2 more minutes. All right, last call for questions. I'll forward my screen to this one as time runs out. So just a few more things. If you have more questions or interest in Azure Cache for Redis, there's a few links there, those aka.ms links that'll take you to the main page and to the documentation for it. And yeah, feel free to follow us on Twitter as well. We always try to tweet the latest news. And if you have questions, feel free to reach out to myself as well. Always happy to talk about Azure Cache for Redis.
Thanks, Kyle. Really appreciate it. And folks, we're going to be posting the recording, and Kyle, will you be able to share the slide deck?
Absolutely.
Yeah, I will share the slide deck as usual on our YouTube channel and the recording as well. Thank you very much. Thanks everyone for joining, and thanks for Kyle E for excellent presentation and demo. Appreciate it.
Of course. Thank you all for listening.
Thank you.
Guys.